We're going to have a look at similar shapes, and two similar shapes are basically exactly the same shape, except one of them can be scaled up. So look at question one. We've got two different squares, and the first square is larger than the second square. But other than that, they are exactly the same shape. Now, we've been asked to calculate the area of the second shape. And as clues, we have the length of the first shape and the area of the first shape, and we have the length of the second shape. So the way to do this is to find measurements that match up. So in the first shape, we have a length of the first shape, and we have a length for the second shape. What doesn't match up are the areas. Now, once you've found your matching set of measurements, what you need to do is divide your new shape by the old shape. So we're going to divide 10.4 by 11.5. And that gives the scale factor, the difference in size between the two shapes. So that's going to give me, type into calculator, 10.4 divided by 11.7. And that'll give a scale factor of, now the answer on your calculator should be 0.8 recurring. So that means if we take the 11.7 and we multiply it by 0.8 recurring, then we get the length of the second shape, 10.4. So again, they're both exactly the same shape, but the second shape is 0.8 recurring of the size of the first shape. Now you might be thinking that if we can multiply the side length by 0.8 recurring to get the new length of the second shape, can we do the same thing to the area and multiply the area by 0.8 recurring? Now we can't, and it's because of the number of dimensions in the shape. Now the scale factor we have found is for a kind of one-dimensional line. But what we want a scale factor for is a two-dimensional area. And the way to think about this is to get an area, you normally do kind of length times width. So you're multiplying two different one-dimensional lines together. And both of those are going to be multiplied by 0.8 recurring. So to find the scale factor of a 2D shape, like an area, we're going to be multiplying by 0.8 recurring twice. We're going to square it, once for the length and once for the width. As you work this out on a calculator, 0.8 recurring squared should give you 0.79. I'm just rounding that to two decimal places. And I think just in case, I think perhaps my answer would be to one decimal place. So we should have one more decimal place to be safe, so we don't have any rounding errors. So a one-dimensional scale factor for lengths is 0.8 recurring, but a two-dimensional scale factor for areas is 0.790. So what we do now is that we take the area of the first shape, 168.2, and because it's an area, we multiply it by the 2D scale factor, 0.790. And that should give us our final answer. And that is 132.9 meters squared to one decimal place. So with question two, we do the same thing. Look at what we've got and we try and find a matching set of measurements. So in the first shape, we have a length and an area. In the second shape, we've only got a length. But the matching set of measurements is that we have a length for both shapes. And so because we have the same dimensional measurement for both shapes, we can find the scale factor. So on your calculator, take the length of the new shape, 14.1, divide it by the length of the old shape, 11.4, and we're getting a scale factor of 1.237 to three decimal places. So that's a scale factor for our one-dimensional lengths. Now we want the scale factor for the 2D area which we're trying to find. So the 2D scale factor is going to be our original scale factor, 1.237 squared. And we can work that out. and to 3 decimal places is going to give us 1.52, and it's 97, so we can round up to 30. So now we have our 2D scale factor. We take our 2D measurement for the area, 148.2. We multiply it by the 2D scale factor, 1.530, and on your calculator you should get 226.7 to 1 decimal place. Now, moving on to question 3, it works the same way, even though it's a 3D shape. So we have a look at what clues we have. We have a 1D measurement, the length for the first shape and the second shape. And we have a 2D measurement for the first shape. It's the cross-sectional area. So there's nothing about volume here. There's nothing about a third dimension. We'll cover that on the medium and hard questions. So we'll look at the scale factor. It's exactly the same. Take your kind of new shape, the shape you're looking for something on. So that's the second shape, and it's 14.8. And divide it by the first shape, which has a 13 for the matching measurement. And that gives us a scale factor of 1.13 to 3 decimal places. Now again, we're looking for a 2D measurement, the cross-sectional area of the second shape, so we need a 2D scale factor. So we take our 1.138, we square it, and that gives us our 2D scale factor. And that should give you 1.296 to 3 decimal places. So just like question 1 and question 2, we take the area of the first shape, we scale it up with the 2D scale factor, because it's a 2D measurement, and we type all of that into our calculator. And that gives us a scale factor of 241.5 to 1 decimal place. Remember, the answer is squared. Yes, it's a 3D shape, but we're not finding a volume, which will be cubed. We're finding an area, the area of one of the faces of the shape. So that'll still be squared. So then for question 4, again, we have the lengths match up. So we divide them. The second divided by the first. And that should give us a scale factor of 1.189 to 3 decimal places. So then again, we need that for 2 dimensions to find the missing area. So we're going to square that scale factor, giving me 1.414 to 3 decimal places. So then multiplying the area of the first shape by my 2D scale factor should be getting 154.9 multiplied by 1.414, 218.976. So to 1 decimal place, we're actually going to round that up. And it will be 219 to 1 decimal place. And it'll still be meters squared. Now you'll notice as we're getting more confident, I'm writing less and less working out. So now for the final question, again, we have the lengths match up. So divide your length in the shape you're trying to find some information out about by the length in the shape you know everything about. And that's giving me a scale factor of 0.883 to 3 decimal places. So then squaring that for my 2D scale factor, and that's giving me 0.781 to 3 decimal places. So now I've got the scale factor, it's just a matter of multiplying it by the area, 167.7, and that's giving me a final answer of 130.9 meters squared. Now, one final thing to mention here is that it looks like for every question, I've been rounding my scale factors to 3 decimal places. Now, that's not actually true, and you might have spotted 1 or 2 inconsistencies perhaps with your working out if you've been following along. Now, what I've actually done is, when I've rounded it to 3 decimal places on the page, I've actually kept the full number on my calculator display, and I've squared the full number, and I've kept that full number and multiplied it by the area. So while it looks like I've been rounding, I've actually been able to do it without rounding by keeping the answers on the calculator and using the answer key to reuse the previous answer. Now, the medium questions start off very similar to the easy questions. So we have a shape, We identify our measurements. You'll have one set of measurements will match up. So in the first question, we have two sets of lengths and one won't, and that's what we're looking for. And for these, it's the volume. But we start off the same way. So we're going to find the scale factor. We're going to divide the two numbers. So the 12.2 divided by the 11.1. And that's giving me 0.099 to 3 decimal places. Now that's a scale factor for 1D measurements, that's where we've got it from, but we're looking for the volume, and so we're going to need a 3D scale factor for the volume. And to find that, we're going to take our 1D scale factor and we're going to cube it. So the easy questions was squared it to find a area. This time we are cubing it to find a volume. And again, I'm not actually rounding it to 3 decimal places and cubing it. I've left the calculation on my calculator with a full calculator display of decimal places. I'm just using the cube button. My calculator says answers cubed, and that's now giving me what I need, which is 1.328 to 3 decimal places. But again, I'm keeping that on the calculator display for future use, so I don't actually lose any accuracy. So now we're going to multiply that by the volume. So 1,439.8 multiplied by the cubed scale factor, and that should give me the final answer. So again, using the answer key on the calculator, I'm typing in the volume, I'm typing multiply, I'm typing the answer key, and that's giving me 1,911.7 to 1 decimal place. And now amounts of volumes will be meters cubed. So doing the same thing for question 2, identifying the matching measurements, dividing them by each other to get the scale factor. And the scale factor I'm getting is 0.962. But of course, we have the volume of the first shape and we want the volume of the second shape. Volume is a 3D measurement. We want a 3D scale factor. We're going to cube our scale factor. So taking the 0.962, it's still on my calculator screen. I'm going to cube it, and that gives me 3D scale factor of 0.891 to 3 decimal places. So now we need to multiply that by the volume, 2,369. And after that multiplication, you should have the final answer. And that's giving me 2,109.8. Actually, there's a 6 after that, so I'm rounding up, so it's 0.9. And again, it's meters cubed. So moving on to question 3, same method, identify what's the same. It's still lengths. Divide them to get the scale factor, 9.3 divided by 12.1. And the scale factor is going to be 0.769. We're looking for the volume, so we need a 3D scale factor. So we're going to cube our answer, and that gives us 0.454. Multiply that by the volume for the final answer, so 1,319.9, and that's giving a final answer of 599.3 to 1 decimal place, and it's still meters cubed. Now, question 4's where it changes slightly, but we follow the same method, and we do find a pair of matching measurements, but this time we have an area in the first shape and an area in the second shape, and they match up. Oh, it's still looking for a volume. Now, again, we're going to follow the same process. We take the number in the second shape, 141.2. We divide that by the number in the first shape, 150.1. And that's going to give us a scale factor. But because both of those numbers are squared, they're both areas to the area of the cross-section of the shape, we've actually found the 2D scale factor. So it's making that clear in my labeling. And I'm getting 0.941 to 3 decimal places. Now, I don't want a 2D scale factor. I want the volume in the second shape. I need a 3D scale factor for the volume. So how do I get from a 2D to a 3D scale factor? Well, we're going to take a ride through the 1D scale factor first. And to go from something that's squared to not squared, we're going to find the square root. And the square root of 0.941 is going to give you 0.969. And then if I'm going to round it to the 9 after that, so I'm going to round the 969 up to 970. But again, I'm keeping the value on my calculator screen. The rounded figure I'm writing down, it's just so the examiner can check and what I'm doing and look at the process and working out. And now I've got my 1D scale factor, I can now find the 3D scale factor by cubing it. So I can cube that answer, and that will give me 0.912. So with any of these, you're always trying to find the kind of 1D scale factor because then you can square or cube it to find the 2 and 3D scale factors. If you're starting off with a 2 or 3D scale factor, then you have to root it to get down to a 1D scale factor. But now I've done that, I can take the value of the volume, 1830.7. I can multiply it by the 3D scale factor I've just found, and I can get my final answer. And that is 1670.3 to 1 decimal place, and it's meters cubed. And moving on to question 5, again, we have a pair of areas. So we're going to start off with a 2D scale factor. Dividing them is going to give us 0.640. So I need to find the 1D scale factor first, and then I can cube that to find the 3D scale factor, which is what I need. So square root my 2D scale factor, and that'll give me 0.800. And then I can cube that to get my 3D scale factor, which will get me 0.512. Writing down my working out to 3 decimal places, but I'm using the full value on my calculator. Now I found the 3D scale factor. We take a 3D measurement, 1938.7, multiply it by the scale factor we've just found, and that gives us a final answer of 992.7 meters cubed. For the hard questions, we now have the volumes match up for both shapes. Again, we're going to follow the same process. So any scale factor we find from the volumes will be a 3D scale factor. So take the volume of the second shape, 3014.2, and divide it by the volume of the first shape, 1782.0, and the scale factor I'm getting is 1.691 to 3 decimal places. Now we look at the shape and look at what we're trying to find, and we're trying to find a cross-sectional area. So area is going to be a 2D scale factor. So we're going to have to go through a 1D scale factor first to get there. So the 1D scale factor, if we have a 3D scale factor, we need to do a cube root. Not just a square root, it has to be a cube root. So look for that button on your calculator. And the 3D scale factor, cube rooted, should get you 1.191. And once you've got the 1D scale factor, you can square it to get the 2D scale factor. And I'm getting 1.4, and then it'll be 20 to 3 decimal places. Now I've got the 2D scale factor, we can take the area, 165.0, and we can multiply it by that scale factor, and that'll give you your final answer, which should be 234.2, and it's an area we've found, so it's meters squared. Let's use that method as well for question 2. So we have matching volumes. So we'll find the 3D scale factor if we divide them. Type them into your calculator, divide them, and I'm getting 0.591. Then we can cube root that to get the 1D scale factor. which is 0.839. And then we can square that to get the 2D scale factor, which is 0.704. So now we've got the 2D scale factor. We can multiply that by the area of the first shape, 146.9. And that should give an answer of 103.4 meters squared to one decimal place. Now, moving on to question 3, same kind of question. We have the volumes, we're looking for an area. Is there a way we can speed this up? So we're going to start off the same way, finding the scale factor. So the 802.9 divided by the 1398.6, and that's give us a scale factor. So 0.574 to 3 decimal places. And that's our 3D scale factor. So what process did we go through in the previous questions? Well, we cube rooted that number and then we squared it. And we're squaring all of the original answer. And so we can express it in a little bit more of a mathematical way. Then we're multiplying that by the area, which for question 3 is 116.5. And so what you can do is we can express the whole thing as a kind of single line equation. And depending on your calculator, you might be able to type all of that into your calculator at once. Now, if your calculator can't handle it, or this is now get confusing for you, just use the old method and just show the individual 2D, 1D, 2D, and final answers as all your lines are working out. It's absolutely fine. But you want a bit more of a shortcut. You want to kind of cut down on the number of calculator button presses, the amount of you writing down on the page, while still showing all the things that you did. This might be a little bit easier for you. And the answer I'm getting is 80.5 to one decimal place, and it'll be meters squared. So trying that again for question 4. The first thing to do is to find the scale factor using these volumes, and we are going to write down the scale factor. So 2,255.5 divided by 1,739.8, and our scale factor is 1.295. Now, to show what we are doing without writing down every single step, we are square rooting that number, and then whatever answer we get from that, we are squaring. Now, on my calculator, I'm just typing in cube root of the answer. I'm then squaring that answer, and then I'm multiplying by the area, 130.8. And now I've got the number on my calculator. So I've done all the steps on my calculator screen, but what I've not done is write down every single individual answer along the way. But I'm still showing the examiner that I'm cube rooting and then squaring. And the answer I'm getting is 155.4 meters squared. So then moving on to the final question. Again, we're working with the volumes. We're going to divide the volumes by each other to get the scale factor. I'm just going to write down one of the scale factors to get, which is the first one, the 3D scale factor. And I'm going to show that to that 3D scale factor, I'm going to cube root it to get the 1D scale factor, and then square it to get the 2D scale factor, and then multiply that scale factor by the area. So now I've shown the examiner that's what I'm doing. On my calculator, I've got the scale factor on my calculator display. I'm cube rooting it. I'm squaring it. Then I'm multiplying it by 164.9. And I'm getting the answer 167.9 meters squared. But again, for you, do the method that makes the most sense to you, that helps you do it, whether that's step by step, pressing equal on the calculator, writing down each individual answer, or trying to put it all into the calculator all at once and expressing it as one big equation.